To understand an air handling unit, it is not hard. You just need a little bit of common sense. As you'll see here, we have an air handling unit that have a supply and extractor fan controlled by two motors. The reason for this, it is because if one motor crashes, the other one should take over. Otherwise, we could lose an important process where the pressure into the rooms has to be kept constant above the atmospheric pressure. Now, as you look to this air handling unit, we got all the heat exchangers, we have the supply fans, we have the pipings, and it is ready to go. So once you finish the design, obviously you will start, and just imagine you start the system, everything runs quite well, you don't have any problem. But let's say to one point you are unlucky enough and one of the motor will crash. You have the human machine interface and the PLC which constantly monitoring the function of the system. If this happens, the PLC will give an instruction to this inverter to stop the motor number 1 and will transfer the function to the inverter number 2 to start the motor number 2 to take over. But it's supposed to be only an electrical failure, because if you have a mechanical failure, unless you have a broken belt, you might disturb the other motor. So the second motor will start. As you'll see, the inverter started, and now the second motor took over and will continue to run the system, so you will not disturb the airflow in some special rooms where the air volume have to be kept constantly. And I'm talking here about maximum 3 minutes. Now, so the second motor is running well, you don't have any problem, and the process is undisturbed. Now we have to find a solution to overcome potential problems like humidity, high temperature, low temperature, and so on. So just imagine you have a rainy day, the humidity is very high outside. So in that case, how can you remove the absolute humidity? You will obviously start the primary cooling coil, because a lot of condensation will happen there and the air will lose a lot of moisture. Then you will reach the second coil, the second cooling coil, where you lose more moisture but the temperature will drop. So to overcome drop in the temperature, I'm using the heating coil as well in the same time with the cooling coil. If outside gets very cold, then I'm going to start the defrost coil and the heating coil to keep the air warm. While I'm doing this, sometime I might have to use a little bit the cooling coil as well, to have an artificial coil just to remove the relative humidity. But mostly I'm going to use the heating coil, because if the winter is dry, it will be my luck. So the winter just gone and the summer comes, the temperature is very high and I have to use intensively the cooling coil. The cooling coil will remove a lot of moisture from the air, and now the humidity can go very low. To prevent that to happen, I can use a humidifier, and the humidifier will raise the humidity into the system. This is a very basic explanation, and I didn't went very deep inside the functionality of this type of AHU. If I'll have some time, I'm going to do it in the future. So this system runs well, but you still have an alarm now, as you'll see it, and that alarm will only disappear if you repair the fan number 1. As you'll see now, the motor number 1 runs and the inverter number 1 runs. It's live again. So because you don't have any fault, you don't have any alarm. The only bad situation which can affect you, it is if you have a massive mechanical failure on the fan bearings, because even if you have two motors, there's nothing you can do, and then you will lose the process, and this is a bad luck. As I said, the system, it is far off being perfect, but at this stage is what we got, and that's it. We don't have anything else. We have to deal with what we have.